Welcome back to another week of some notes. This section should be fairly easy with the use of Desmos, so make sure that you have access to Desmos. But it's very important because we will use it every single unit from here on out. It's going to make solving equations so much easier. So if you think about in Algebra 1, they always made you do this step and then this step and then this step, show all your work, so forth and so on. For class, we're no longer going to have to do that. So we're going to be able to use graphing technology instead. So we're going to use a graph to solve an equation. So Algebra 1, you would add 12 to get 15. 5x equals 15. Divide by 5. So x equals 3 if we do it the traditional way, right? So let me put those out in steps there. Algebra 1 made you do this. And maybe you had to do it some in geometry when solving. Okay? Now, what does that look like if I'm going to use a graph? That makes it sound harder, but I promise it's easier. So you're going to split at the equal sign. Okay. So we need to remember 5x minus 12. We need to remember 3. In Desmos, I'm going to go over here and say y equals 5x minus 12. And then in y2, I'm going to put y equals 3. So notice what I did here. I took the equation and put each expression in as y equals. So right here, 5x minus 12, y equals 3. I look for the intersection point. The intersection point is 3, 3. So I'm going to make a little note here. Because remember, these are our notes that we look back on in case we need help with another one. 3, 3. I always use the x value only because notice there is no y in this equation. So I only care about the x value to get x equals 3. Okay? So again, we can do that with any equation. If we have absolute values, if we have quadratics, so that parabola, that's the word I'm looking for. All of those things we can graph with. If it intersects twice, that just means that x equals 2 things. So if I had something like this, where it crosses here and here, it just means x equals this answer and x equals this answer. So try the other one on your own, and then try a practice problem. Welcome back. For example 2, we're going to be using Desmos again, so make sure that you still have access to that. And I'm going to go ahead and draw myself a little graph over here because in my notes I always like to have a picture of what I graphed in order to get it right. So in this one we're solving an inequality. Okay, that means that it's not just equal to, but maybe it's less than, or maybe it's greater than, maybe it's both. So a little actually, we're going to do this after we graph. So let's go graph first. So x squared plus 6x plus 5. Here's how we graph it. Go to Desmos. Clear out what's there from the last example. Okay, in our first example, we're going to use in the first line, not example, the whole thing's the example. X squared plus 6x plus 5. And my parabola looks like this. Perfect. It has two x-intercepts. We're happy. Now, in our second one, we're going to say y, and then whatever inequality symbol we had. So in this case, we have greater than or equal to 0. So we're going to do greater than or equal to 0. And my graph now looks like this. I'm going to see if I can change it. I think orange is a little lighter. You can see a little better. Giving us some fall vibes here. Okay. No, we don't care about that one. We want that one. So, -5 and -1 are our special points. Let's look here. So, oh, I'm on eraser. So, -1 and -5 were our special points. And then we had all shading. So, if I use a highlighter, all my shading was up here, right? All right. So that means that this piece works and this piece of the graph works. And of course in math, we don't say this piece, that piece. Instead, so I think about this at x is at -5 and it's going left. Left is smaller. So we put less than or equal to. Or, because it's a second piece, special things happening at -1, it's going right. So thinking right is getting bigger. So that's greater than or equal to -1. So this is my answer. Okay, I'm going to use my blank space in the workbook over here and check something out. What happens if I said same problem but less than or equal to? How does it change? So in Desmos, what happens when I change this to less than or equal to 0? Okay, well, only one thing changes. It's now highlighted below instead of above. Okay, so this part is the same. -1 and -5 are our two sweet spots. But that was a bad highlight. Let's get a little more accurate here. It's our notes. Okay, so right there. All right. This time we have one connected piece between 2 points. So that to say between, I put X between the two numbers, smallest to largest. So smallest number is -5, largest number is -1. And then I use the less than or equal to symbols in between. So all of your answers will either look like this or this. This is a statement to say it's all the numbers in between. This is a statement to say it's all the numbers on both sides, so everything but what's in between. But both, depending on the way that your question is set up, could possibly be answers that you will be doing. So try your next problem and then move on to example 4. So for our last example, yes, you heard right, last example, only 3 short videos today. It is actually kind of the same as what we've been doing. Judging by what's being said, so we're going to use that graphing technology to approximate the solutions to the nearest tenth, should clue you in that maybe we won't get pretty numbers as an answer, meaning that we will have to round. So the nearest tenth means 1 decimal place. So make sure that you remember that. All right, so just like before, we're going to put the left side in the first line, the right side of the equal sign in the second line. This is a case where you do not have to use y equals unless you just want to. You only have to use y equals when it's a number by itself with no sort of x or anything fancy with it. Okay, So my graphs look something like this. And again, we care about the intersections. So in this case, here are my intersections. I did a little prep work. If it works out well, let's see. Maybe. Okay, let's do it here. Yeah, there we go. So I took a screenshot and put it in the notes here so that we can reference it. But as you saw, I did do it live. So other than a color change, it's the same picture. And yes, you're seeing all of these information things. Let those go. All right. For our final answer, we only use the X values. So I do not use the Y values because there's no Y here. I'm only solving for X, okay? I'm going to round these decimals to 1 decimal place so that Envision will count it correct. So X equals negative 3.3 and X equals 1.79, but if I round that up, that's 1.8 as my answer. So this would be the final answer that I would type into Envision. Envision likes you to separate it by commas. One last thing that you may see is instead of saying equal to, remember the whole mathematicians are lazy, and this wasn't an exact answer. It was approximate, so about right there. They do have a symbol for approximately, and it is a wavy equal to sign. So a wavy equal to sign means approximately. Okay. All right, you are ready to finish your last problem in the notes. Do the example in 1-.